So we want to demonstrate that for every natural number, 4 to the n minus 1 is a multiple of 3. Now, before we attempt anything, I'd like to see what is the format of the statement. So note that this may be transformed into something of this kind. For every n in the collection of natural numbers, including 0, of course, P of n, where P of n is the following predicate. 4 to the n minus 1 is a multiple of 3. Okay, so this is a perfect candidate for an attempt to prove it by induction. So what can we do? Well, as usual, every proof by induction contains two things. First, the base case. So we want to examine the following statement. 4 to the 0 minus 1, of course, is equal to 0, which we may rewrite as 0 times 3. So we can say that 4 to the 0 minus 1 is a multiple of 3. Now, that constitutes the base case of the induction. To look for the second part, which is inductive step. We would do something along these lines. So let K be some natural number and assume that 4 to the power of K minus 1 is a multiple of 3. Well, ultimately, we want to demonstrate that 4 to the power of K plus 1 minus 1 is a multiple of 3. Well, but in order to get to that point, we have to reinterpret this. So then 4 to the power of K minus 1 might be written as the following: 3 times R for some integer R. Right? Well, then I have 4 to the power of K plus 1 minus 1 should be written at some point as 3 times some other integer. The question is which one? Well, in any proof by induction, especially in the inductive step, we would like to be able to introduce the assumption. So is there a way in which I can express this using this? Well, to some extent, look, I can write this as 4 times 4 to the K minus 1. And I'm allowed to do this because K plus 1, well, certainly is greater or equal to 1. So I can extract one of the powers. But from here, look, I don't know if I can extract this, but certainly I can make a trick. I have a multiple of 4 here, so you need to find a way to include a negative 1. But to include a negative 1 and to factor it by 4, I have to include a negative 4, but I will have to add it. So this is what we call a zero-sum trick. So I have 4 times 4 to the power of K minus 4 plus 4 minus 1. And observe that this is nothing but 0. Right? So I'm not affecting this equality. Well, but while doing that, look, I gained some extra powers because now I can do this 4 times 4 to the power of K minus 4 plus 3. But from here, I'm going to factor 4, and I'll obtain 4 to the power of K minus 1 plus 3. And as I promised, we will be able to use the assumption because we never used it so far. So now we're going to introduce it and say, well, but by assumption, this expression has to be 3 times R. So this is 4 times 3 times R plus 3. But now look, from this one, I may extract the 3. Both are multiples of 3. So I have 3 times 4r plus 1. Well, I know that r is an integer. So I have that 4r plus 1 is also an integer. Then the expression that I have here, 4k plus 1 minus 1, is a multiple of 3. And that completes our proof by induction.